Hi everyone, thanks for joining me again. In this video, we're going to be exploring multi-agent frameworks. So specifically, I've created a small project here, and I'll be running through the notebook for that project, where we are using a multi-agent approach to open domain question answering. Essentially, we are taking a query from a user, a question, a task, and then we're looking for a Wikipedia knowledge base, and then indexing that, conducting some semantic search over that index to respond to the query. This is essentially RAG with a multi-agent twist. What got me excited about multi-agent workflows was firstly the release of the ChatDev project, which is essentially just a software company entirely powered by large language model agents. I think what's amazing is that ChatDev have set high-level roles like the CTO and CEO that are prompted to deliver strategy at a high level. And they've also set lower level roles that actually write the code to create the software. And there are operational processes embedded within the workflow, things like testing and feedback loops. I think what they have shown is the ability of multiple agents to work together to deliver complex objectives. The other thing that got me excited about this was the release of the AutoGen framework, which has made it feasible to actually create your own multi-agent workflows. There are obviously frameworks out there that allow you to create large language model powered agents, but many of them don't actually facilitate the collaborative agent framework or the multi-agent framework. Now, I will be running for a notebook for this open domain question answering project that I've created. I'll be running through this at pace, but there is a technical blog that accompanies this video, and I will be providing the link to the GitHub repository so that you can go through the code yourself or alongside me while you're watching this video. And that should give you a full picture of what's happening and how to leverage the AutoGen framework to create your own multi-agent workflows. As always, the links to all of the resources are going to be in the description for this video. As soon as the technical blog is published, it will appear there as well. Okay, let's get into it. Seeing on screen now is the notebook with the open domain question answering project in here. So there's a few things that you should know if you're following along and you want to use this notebook yourself. First of all, there's some setup things here. So there's a configurations.json file that accompanies this notebook, and it's going to be provided in the GitHub repo. Essentially, you need to go into that configurations.json file and enter your own OpenAI API key. So if you don't have an OpenAI API key, you should probably get one before you attempt to follow along with this notebook, if you intend on running the code yourself. The second thing to be aware of here is that the process itself, we're making multiple calls to large language models in a row, and depending on the complexity of the question you're asking, it could be numerous calls here. So you are going to use more credits than you might be used to if you're just used to making single calls to that OpenAI API. So just be mindful of that. So I have set the default model here to GPT-4 Turbo. So this is what it says here, GPT-4 Turbo, and that's the preview version. You're free to change this. So just head into the configurations.json file and change the models that are set there, and then ensure you change it here as well. However, I would say that the workflow is most performant with GPT-4 Turbo. I have tried it with 3.5 as well, which is obviously the cheaper endpoint, but the workflow doesn't really perform as well with GPT 3.5. So I would stick to using GPT-4 Turbo if you can. It's also important to know, or you should know, that OpenAI have actually made the GPT-4 Turbo endpoint cheaper than the GPT-4 endpoint. So that was announced in their dev day yesterday. Just be aware of that as well. So that will impact the cost of running this notebook. And obviously you want to change the file paths here. So you want to link to the index path, which is a folder that will be provided in the GitHub repo as well. So you want to link to that wherever that is locally on your computer. And you should also link to the configurations file as well. And that should be in the same folder as the notebook. Great. So that's just some basic setup stuff. Let's work through the notebook. So as I mentioned earlier, it's best to read the technical blog and work through this notebook and also listen to the video, because it's going to give you a fuller picture of what's going on. I'm working through this at pace, so I'm going to skip a few of the details here. But the first thing I'm doing here is defining the tools. So if you've worked with large language model based agents before, what you'll know is that agents have the ability to use tools. Tools in this case are just Python functions that the agents can execute. And they can also produce inputs for those functions, as long as those inputs are of a natural language nature, for example. So for this open domain question answering, there are two tools that I have defined. The first tool is essentially like a Wikipedia search and index tool. So what that does is it visits a Wikipedia. What it does actually is it takes a query and searches that on the Wikipedia search engine, returns the search engine results page. So that query is going to be something relevant to the task, and then takes the titles of those pages and downloads them for indexing. And then it actually indexes those Wikipedia pages, and that indexing is done with Llama Index. So that's the first tool. The first tool is essentially locating relevant pages on Wikipedia, downloading those and indexing them. And that process is done using a combination of the Wikipedia API and also Llama Index. The second tool operates on those indexed Wikipedia pages, which I'll refer to as the knowledge base. So what it does is it actually performs a semantic search over that knowledge base. And that semantic search is obviously to answer the query or respond to the task that was submitted to the agent workflow. All of the tools are defined in this section of the notebook. So, where we hit define tools, you can run through this yourself in detail to just see how those tools work as functions. I'm not going to run through the details just to keep this video relatively short, but yeah, you will have this available to you to look through in your own time. A quick side note on the tools as well that's important to know. I have set these tools up, so the search tools specifically, so I've set both search tools up, apologies. So the searching of the knowledge base and also searching for relevant Wikipedia knowledge and downloading that and indexing it. So this search component I've set up to perform multi-hop question answering or multi-hop searches. So essentially, this is where we need to answer a question from disparate sources. So this could be 2 hops, which would mean 2 disparate sources that contain the relevant information to answer that question. It could be 3 hops, which is 3 disparate sources, 4, and so on. So I've put in a rudimentary search, a rudimentary loop to be able to facilitate multi-hop question answering over those Wikipedia pages. Okay, so that's all in here, and all the logic should be transparent to you within the code itself. So the next part is actually the function calling component. And I have written an article on function calling. So if you're not familiar with function calling, I think, before you get into any kind of agent workflows, it's probably a good idea to familiarize yourself with function calling. It's a really powerful tool by OpenAI, but it is essential to making these multi-agent workflows work with, if you want to include tool usage in those workflows as well, which you probably will want to include because it's just really useful. So essentially what function calling does is it enables your large language model powered agent to interact with your tools by generating the inputs to those functions. So it's best to kind of illustrate this with an example. So I talked about the 2 tools that I've previously defined. So the first one is the search and index Wikipedia tool. So this tool actually takes 1 input, which is the hops, right? So this is, based on this multi-hop question answering that I've described, right? So the hop will be a list of queries that we want to search in Wikipedia. And that list of queries will facilitate us answering the question that has been posed to the agents. Now, what function calling enables you to do is, well, what function calling does is it helps the agents interpret that function, understand what that function does, and provide inputs to effectively use that function. And the way it does it is by leveraging these descriptions. So the first description here describes what the function does. So we're saying it indexes Wikipedia pages based on specific queries for each hop to build a knowledge base for future reference. And then we've even mentioned an order here. So it's saying use before the query wiki index. And then we define, so a lot of this is boilerplate around here, but the important parts are obviously the name of the function, the description here, and then the arguments of that function. So hops is the argument, and then we have a description for this. So we have a type, it's a string, and then we have a description. So the description here is the search queries for identifying relevant Wikipedia pages to index, each corresponding to a hop in a multi-hop question. So what our large language model powered agent is going to do is it's going to interpret those descriptions, and it's going to be able to return the hops to input into these functions in order to effectively search and index relevant Wikipedia pages. So that's what the function call does for that tool. And then if we move down to the query wiki index tool, we have a description here. So this queries the indexed Wikipedia knowledge base to retrieve pertinent information across multiple hops. Okay. And then again, the argument here for this function is hops. And then the description here is the search queries to search the indexed Wikipedia knowledge base for relevant information, each corresponding to a hop in the multi-hop question. So essentially what we're doing is once we've indexed the relevant knowledge, we do semantic search, but in a multi-hop fashion. So, you know, because there's different parts of that index knowledge base that are going to answer different parts, or they're going to pull the disparate information we need to answer a multi-hop question. I will flag here as well that even though I've set this up for multi-hop question answering, it does work if there is just one hop, if there's less than 2 hops in the question, if there's just 1 hop, for example. I don't know if that's the right term to use, but it does work for questions that are not multi-hop questions, basically. Fantastic. So we set this all up. So the function calls are important, but this is all set up in our LLM configurations. And there's some standard configurations here that you'll see. This config list is obviously coming from what we defined at the top that has our models set there. So it should all make sense once you see the code. But essentially, we will be passing these configurations to the various agents in our workflow. There is also a configuration here that excludes the functions. So that's essentially excluding the tools, because there are going to be agents in the workflow that do not use the tools. And the reason for that will become more obvious. If you read the technical blog, I've explained why there's some agents that don't use the tools in the workflow as well. Great. Now let's move on to the interesting part, which is the AutoGen framework. So this is how we are going to build our multi-agent workflow. And I'll start here by just talking about the AutoGen, the generic agent classes that I've used from AutoGen. So these generic agent classes they have certain capabilities just out the box, and I've used 3 different types of them. So the first one is the user proxy. So the user proxy has the ability to execute our functions. That's kind of the primary goal of the user proxy here. The second one is the assistant agent. So that class of agent has the ability to perform natural language understanding or natural language processing tasks, and it is powered by a large language model. The third type of agent is the group chat manager, and that orchestrates the communication or the collaboration between all of the agents that we are using in our multi-agent workflow. Now, that's kind of the vanilla agents that are supplied to you. So these are the classes that come out of the box from AutoGen. What's interesting is you can modify those classes to behave in particular ways, and that's how you create your specialized agents. And the way you do that is by putting in a system message, and that's essentially creating a prompt that influences the behavior of that agent. So I'm going to get into that. in a second. But first, I want to show you the workflow that I have built for this multi-agent approach. That will give you a better picture of what's happening and how, we've turned this kind of standard RAG question answering task into a multi-agent task. So hopefully on screen, what you should see is the RAG workflow. Hopefully on screen, what you should see now is the multi-agent workflow. So essentially you have your group chat manager at the top. And then within this, you have the user proxy agent. And the user proxy agent, or the job of the user proxy agent, is to simply execute the functions. So it doesn't do anything clever. It just takes an input to that function, which is the hops, and then executes it and produces an output. That's all the user proxy agent does. And it does that for our two functions, the one to search and index the Wikipedia pages, and the other, which is going to perform the semantic search over those indexed Wikipedia pages. Right. So then we've got the assistant agents. But what I've done is I've obviously created prompts to modify the behavior of the assistant agents to fit into different roles. So our first assistant agent is the analyst. So the analyst's job is to take the query and basically create hops to answer that query. So the analyst is providing inputs to the search tools. So the first, if you imagine, for example, a query could be something like, what is the population of London? The analyst will take that query and decide, okay, is it a multi-hop question? Or does it need to kind of separate that out into multiple hops? And it will come up with search terms that will feed this search and index tool to search Wikipedia and ultimately, be used by the user proxy agent to download the relevant pages. So the user proxy agent isn't coming up with the inputs to the tool. The analyst is doing that. So we've specialized the analyst, or the analyst is a specialist in doing that. And that's doing it for the search and index tool, and it's doing it for the query index tool. And, it is designed to do this for multi-hop questions as well as just single hop questions as well. So that's going to become more obvious as I step through the code and we demo how it works. Okay. So once we have delivered our outputs from the user proxy, the next stage is going to the reporter. So the reporter takes the retrieved context, which is obviously generated from searching our index, and takes the initial query into the agent workflow and generates a response. So that initial response is like a draft, essentially. So note that the reporter is also an assistant agent, but it does not actually have access to any tools. It only has access to the retrieved context and also the query, right? So the reporter is not doing anything with the tools. It's just taking the retrieved context and the query and generating an answer for us. That's why it's I've given it the name reporter. Then the reporter feeds to the moderator. And this is where it kind of gets a little bit more sophisticated. The moderator reviews the output from the reporter and essentially signs it off. So it will either sign it off saying, yes, this is great, proceed with the final response, or it will say, this doesn't meet the standards that I have set, please review, and it will give it the reasons why it doesn't meet the standards. And so there's a feedback loop there, and the reporter can regenerate the response to meet the standards of the moderator. And that is essentially it for the agent workflow. And that's a really high level. But just to recap, we have our three types of agents represented here. So we have the group chat manager, and the group chat manager just facilitates the collaboration between all of these agents. We have the user proxy, and the user proxy is, it's a bit like a dumb agent. So all it does is execute the tools. It doesn't even decide the inputs to those tools, just executes the tools and produces the outputs. The analyst decides the inputs to those tools based on what is required to search Wikipedia for the relevant information. So you'll see how that works when we demo the actual workflow. The reporter that is another assistant agent, but it's prompted to just generate a response. So generate a response based on the retrieved context from the index search and also the query. And the moderator is there to review the reporter's response and ensure that it meets the standards that we have set. And that's it. Then you deliver your response. So that's essentially retrieval augmented generation with a multi-agent twist. Perfect. AutoGen makes it really easy to set this workflow up. We start off by using the agent classes provided to us. So we have the user proxy agent here, for example. That's a class just readily available from AutoGen. And then we set our parameters. So we give it a name. So we give it a termination message. So all this means is it's just terminating the workflow when it sees this, when an agent returns terminate. Human input mode is never. So you can actually have human input to the user proxy, and that can act as a measure of feedback as well. But for the purpose of this task, I've set it to never. And then you can set your max consecutive auto replies, and that should actually limit the amount of calls you're making to the large language model as well. You want this to be enough to complete most of the tasks that you'd like it to complete, but you don't want it to be too many because you could get stuck in loops that will ultimately cost you a lot of money. So that's the user proxy agent. And that is just using that user proxy agent class available to us. So then we've got our first assistant agent, which is the analyst. And the analyst, there's a system message here that gets it to behave like the analyst. And, you know, I've explained what the analyst does already, but I would just have a look at the prompt and get your head around exactly what this analyst is doing. And the main thing to take away here is that the system messages can adapt the behavior of the assistant agent in a direction that we want it to adapt for the workflow. So the analyst actually is using the LLM config. And if you recall from before, the LLM config also has that list of function, or that dictionary of function calls. And those function calls mean that analyst has access to the tools, okay? And we need the analyst to have access to the tools because it needs to tell us the inputs to those functions, which is the number, not the number of hops, but the hops themselves, like what queries we're going to use to index Wikipedia and what queries we're going to use to search that index after it's been indexed, okay? And then we have the reporter, and again, we're adapting the system message here to get the reporter to behave as we want it to. And then notice here under the LLM config, we've got the LLM config with no tools. So the reporter doesn't have access to tools. We don't want it to have access to the tools. We just want it to simply produce the output based on the generated context. And that will become clear as I run through as I demo the workflow. And then lastly, we have the moderator, and that is, again, another assistant agent. We've got a message here to prompt the moderator to behave as we want it to. And again, the LLM config here is the one without tools because we do not want the moderator to have access to tools. So there's a few last steps here. So one of the steps here is to actually give the user proxy access to tools by registering those tools. So you need to register those functions with the user proxy, and that's easy enough to do here. This code is pretty self-explanatory. And then finally, what we want to do is we want to set up the group chat. And the group chat is the context in which all our agents can collaborate. And the group chat, of course, needs a group chat manager. So we set up the group chat manager like so, and that's another class available to us. And we can also adapt the system message to make sure the group chat manager follows the workflow that we want. And I have written something here to make sure that it does follow that workflow smoothly every single time. And that is it. And we can pretty much initiate the chat from here. There's a few notes before I demo this. It is quite tough to get these agents to work well together. It required a lot of prompt engineering on my side to make sure the agents were doing the job. You've got to be very precise with your instructions as usual. And because you're working across multiple agents this time, you don't want them to interact with each other in the wrong way. So that is just a cautionary tale for anyone looking to work on this. And if you're a newbie, just be prepared to spend a lot of credits because probably the workflow that you want to create, you're not going to get the prompts right the first time, I would imagine. Okay, so I will now proceed to demo the workflow on some multi-hop questions. And hopefully, I haven't tried these questions out before, so we'll try them out live together and hopefully they should work. And let's go. Okay, so hopefully you should be able to see the multi-hop questions I have on screen now. This is just taken from a random paper on multi-hop question answering that was delivered back in 2022. I'll link the paper in the description to this video. Essentially, you have a series of multi-hop questions here, ranging from 2 hops to 4 hops. The 4-hop questions are obviously more difficult to answer than the 2-hop questions. I'm going to take a few of these and run them through the workflow just to see how the multi-agent workflow copes. So let's take the first one here. Who succeeded the first president of Namibia, right? So according to this paper, that is a 2-hop question. You'd have to first know who the first president of Namibia was, which is Sam Nujoma, and then who succeeded Sam Nujoma, which is Hifikepunye Pohamba, right? Let's see how the workflow works with this. So I've just initiated the chat with our question, and you can see now the first agent to receive that is the analyst, and the analyst has found the 2 hops, so the first president of Namibia and the successor of the first president of Namibia, and it's going to proceed to suggest these as inputs to the search and index Wikipedia tool. So that has been suggested as an input, and it's returned these pages. So it's preparing to download the president of Namibia, vice president of Namibia, history of Namibia, and Namibia itself. Apparently, these are the pages that contain the correct information or contain information that is relevant to these search terms. Remember, the tool is just using the Wikipedia search engine on these terms, and these terms are what the analyst has come up with. So you can see that it's being executed here by the user proxy. So the user proxy has actually returned a response. And now we're on to the second tool, which is the query index tool. And notice that I have outlined that it needs to index the Wikipedia page first and then use the query index tool. And we've got some context returned back, and that is sent to the reporter. And the reporter has delivered us an output saying, please review. The moderator has reviewed that output and approved it, and that's the end of the workflow. What's interesting here, or what's cool here, is we've been provided with an answer, and the answer is Hifikepunye Pohamba, and if I'm butchering that name, apologies. And it's even identified that, you know, it succeeded, he succeeded Sam Nujoma as the president of Namibia. And we've got some more information about stepping down in 2005 and so on and so forth. And then there's actually a reference given. Interestingly enough, we indexed a few Wikipedia pages there, but we've been referenced to the history of Namibia. Let's just jump into this just to make sure that this actually makes sense as an answer. So we know that this is the answer. There is always a chance that this knowledge could be embedded in the model, but it's good to see if it was pulled from the context. So let's have a look. Let's search. There we go. So yes, that is indeed correct. So transition from a 15-year rule of President Sam Nujoma to his successor Hifikepunye Pohamba in 2005 went smoothly. That context is within the reference that we've been provided. So it looks like the agent or the retrieval process worked. The entire workflow seems to have worked well to pull that information from the Wikipedia page. And there we have it. So that's fantastic. Okay, so that was a 2-hop question. Let's move on to something a little more complex, and we will do a 3-hop question. I'll pick something. Let's pick the next one down. So what currency is used where Billy Giles died? And apparently this is a 3-hop question because you need to know the location that Billy Giles died, which is Belfast. What part of the UK is Belfast located, which is Northern Ireland. And then you would also need to know the unit of currency of Northern Ireland, pound sterling. Okay, so let's give it a try and see how the workflow copes with that free hop question. We'll enter this into the to initiate the chat and then run that cell. So we're executing the search and index, and yeah, pay attention again. So actually, the analyst doesn't think it's a free hop question; it thinks it's a two hop question. We've got Billy Giles here and currency used where Billy Giles died as two search results, or two search inputs, or two hops to the search index Wikipedia tool. And then we have identified some relevant pages by leveraging that Wikipedia search engine API. We're preparing to download Billy Giles, John Ketley, John Maynard Keynes, and Mao Zedong. That's quite random. Let's see if that corrects. Well, it hasn't corrected itself. We are actually downloading those pages. Obviously, some of those don't seem to make sense to what we're trying to do here. That's great. We have downloaded those pages. And then we've got the analyst has again identified some search terms to actually search the index. So we've got Billy Giles and currency used where Billy Giles died. Great. And the user proxy has taken that input, used the query wiki index tool and returned some context. The reporter has taken that context and returned an answer. The moderator has reviewed the answer and approved it. And the message, the workflow should terminate. Nah, so the workflow has terminated. Fantastic. Okay, so Billy Giles died in Belfast, Northern Ireland, and the currency used in Northern Ireland is pound sterling. Okay, just for comfort, we'll check back at the paper. I know the answer to some of those questions already, so I know, yeah, currency used in Northern Ireland is pound sterling, and Billy Giles died in Belfast. So we got the answer correct, but let's just have a look to see if it was pulled from the context, because yes, as you may know, large language models do have some of this knowledge inherent within them. Okay, so let's so Belfast, Northern Ireland, so that is actually within the context for this page, which is fantastic. And that was for the first reference. And let's have a look where we're referencing that in the text here, just to make sure that actually makes sense. Ooh. Here we go. Apologies. Yeah, that reference aligns. And then let's have a look at the second reference. And hopefully we should be able to find here we go. Currency, pound sterling. Fantastic. That's it. So that appears to work well. Let's move on to another question. We can look at another. How about we look at a different free hop question? The structure of this free hop question is a bit different. You can see this from the graph here. The question is, when was the first establishment that McDonaldization is named after? McDonaldization is named after. Open in the country Horndean is located. Okay, so that doesn't make any sense to me, if I'm being honest with you, but the answer is 1974. I'll try to read that again. When was the first establishment that McDonaldization is named after? Open in the country Horndean is located. Right. Okay. Let's give it a try and see how our multi-agent workflow works with that. Right. I will run this. I have no idea what this is going to do because I don't really even understand that question. Okay. We have identified 3 hops, McDonaldization, which I have no idea what that is. First McDonald's restaurant and Horndean. It seems like the analyst is probably better than I am at interpreting that question and deciding what it means and what the appropriate search terms should be. And we're running the search on the search and index Wikipedia tool. That's being executed by the user proxy. And we can see what pages we're preparing to download. So McDonaldization, The McDonaldization of society, oldest McDonald's restaurant, list of countries with McDonald's restaurants, Horndean. There are a few, Horndean FC. So that looks like Horndean has a football club, apparently. We'll see how that's relevant, or whether it is relevant at all. There's quite a few pages that we're putting there. It does take a little bit of time. It looks like there's been an error on GitHub, but it is actually re-indexing. That's quite good. So there is error handling in this tool, obviously. So the re-indexing is happening here, which is good. Great. So we have finished downloading the pages. We've got our pages indexed, and now we're executing the query wiki index. And we have our different hops being searched here. So our 3 hops being searched on the query wiki index. Notice that the pattern is being followed every single time. So every single time we are indexing, querying, and then doing returning the response from the reporter. And it's the same agents performing that. Information gathering complete. That is actually a prompt that I have included in the analyst agent. It doesn't always do it, and that kind of shows you the difficulty of sometimes getting these agents to execute in exactly the way you want. But in general, it seems to work as it should. And we have an answer, and the reporter has flagged to terminate. Right. So the first establishment that McDonald'sization is named after, which is McDonald's, was opened by Richard Maurice. McDonald's, California. The restaurant was a tiny octagonal building, which was later moved, blah, blah, blah. However, first McDonald's restaurant was simplified assembly principles. This is quite long, 19. Right. As for Horndean, it's a village, civil parish of Hampshire. Horndean is located in the United Kingdom, and the first restaurant in the United Kingdom opened in Woolwich, southeast London, November 13, 1974. Right, let's just have a look at what the correct answer is. And funny enough, that is the correct answer, 1974. There's a lot there. There are a lot of references. I don't think I'm going to check through all of those references right now, but you can see that it has pretty much been able to answer the question and provide the correct response to that question. Not only that, it also provides references there as well. That is pretty impressive for the agent workflow, considering I wouldn't have been able to answer that question because I had no idea what it was talking about. It's pretty impressive that the workflow was able to do that end to end. All right, we'll try one more. We'll try one of the 4 hop questions. I have already tried this one, so the German one and that is linked in the article, so you can review the agent trace yourself when you're reading the article. Let's try this one. Let's try the Napoleon one, and I will grab that. And I will move that up, and let's just see if we can get an answer to the Napoleon one. So the question here is, when did Napoleon occupy the city where the mother of the woman who brought Louis XVI style to the court died? Again, this kind of sounds like gibberish to me. I'm sure if you sat down and you could work it out, but here we go. So that is a 4-hop question, and we'll proceed to ask the workflow. And we have identified, it seems we've only identified 3 hops here. So our analyst has only been able to pick out 3 hops, which is already concerning given that it's a 4-hop question. We're hoping that the analyst would be able to identify all 4 hops, and maybe that means that it won't be able to pick out the answer. We're now obviously executing the search and index Wikipedia tool. We finished downloading the pages. No errors this time, or no errors that mean that we need to kickstart the process again this time, which is good. Another thing to note is you get error 500 codes sometimes if you run too many calls to the OpenAI endpoint. So it's just something to be mindful of. I think there is a limit to the types of workflows that you can build in that sense, and it's limited by the API bottleneck. Just be mindful of that, because it will retry the API every 10 seconds, but you could go for about 20 calls before you get through. Just be mindful of that. You'll get error 500 codes if you set these workflows up to be too intensive. We have managed to retrieve some context, and now we are querying the wiki index. Great. So we've got the context to feed to the reporter, and the reporter has come up with a message. Hopefully we should have that reviewed by the moderator. The moderator says approve the answer, and we will step out of this workflow. Terminate, and that should end the workflow. Fantastic. Okay. So here we go. This is quite a long answer, but ultimately what we've got here is 1814. I will perhaps step through this. What I'll do to make it easier is I think I'm going to just put this into a text. I'm going to put that answer into a text file, so it's just easier to read. Right, okay, so this is coming from the reporter. I'm just going to copy and paste that and put it into a text file. Let's see if you can perhaps just... Yeah. I'm going to bring that up on screen now, and that's just what I've grabbed. Apologies. I'll bring that up on screen, and that's what I've grabbed from the notebook. Okay. The query involves linking several pieces of historical information. Firstly, we must identify the woman who brought the Louis XVI style to court. This woman is Marie Theresa. I'm just going to pronounce it Teresa. Apologies again if I am pronouncing that incorrectly. Let's just see if that is a thing. So no, we've got that wrong. It was Marie Antoinette, according to this paper. I am going to jump in and double check that with the Wikipedia page, but apparently it's Marie Antoinette. But we're saying Marie Theresa. This woman is Marie Theresa, Duchess of Angoulême. I'm not sure how to pronounce that. The daughter of Marie Antoinette. I think we have that the other way around. I'm just going to confirm that in the Wikipedia page, but yeah, Marie, whose mother of Marie Antoinette is Marie. So we have that the other way around. Interesting. In what city did Marie Theresa die? Vienna. And then when did Napoleon occupy Vienna? 1805. So what have we got? Her mother, Marie Antoinette, died in Paris, which was occupied by Napoleon's forces during the later stage of his rule in 1814. Interesting. So it kind of all depends on whether the workflow has got that the right way around. And luckily we actually have the references. So we've got the reference here saying that Marie Theresa, Duchess of Angoulême, the daughter of Marie Antoinette and Louis 16th, which is the first reference. So we can get into that. Was the eldest child of King Louis and Queen Marie Antoinette. So it looks like the workflow that we have is correct. Let me just verify that. I'm going to bring both up simultaneously because it might well be that the paper itself is incorrect. So what we have is this woman is Dutch, and the daughter of Marie Antoinette was the eldest child of and Queen Marie Antoinette. So what we have retrieved using the multi-agent workflow is correct. And actually, this example here is not correct. They've got it the wrong way around. So I'll assume that the other responses are going to be correct, assuming that we've managed to work through that multi hop question in the right way. And that's the beauty of pulling the references. We can always double check the facts that we pull back, which is incredible. Okay, that is pretty much it for the demonstration. It has been a long video, even though I've tried to move through this at pace. Hopefully you now understand the power of multi-agent frameworks, multi-agent workflows, and hopefully you understand a bit about how to use AutoGen as a multi-agent framework to create your multi-agent workflows. I have found using AutoGen I found it interesting, let's say that. It took me a while to get my head around it. It took me a while to understand some of the concepts and put things together and get the agents to work together in the way I wanted to. Ultimately, with any of these types of agent workflows, it always requires more prompt engineering than you first anticipate. And it took me a lot of time experimenting to get those prompts right. But I'm excited to see where the framework goes. And there is a lot more to it than I have demoed on this video. I would implore you to check out the documentation for AutoGen and see maybe what you can build yourself. If you want, have a try of different questions using this workflow. It'll be interesting to see what you're able to pull from there. You can verify a lot of the questions that we've run together in the chat. You can verify that in your own time. And that is pretty much it for this short, or not short, but that is pretty much it for this quick run through of the notebook. Like I said, the technical blog is going to be available and will be linked in the description as soon as it's published. You will find the GitHub repository for this project also linked in the description. And I'll link the paper to the function calling as well, and any other useful resources that you might need. If you found this informative, I would really appreciate if you liked this video, share it as well. If you haven't already subscribed to the channel, because I will be producing more content on artificial intelligence, data science, large language models, agents, you name it. I'm going to be producing content on all of that stuff. In the next few videos, I'll be doing some content on the Dev Day, OpenAI's Dev Day releases. So that's going to be around their agent API, the GPTs. I'll also be looking to do some content on some of the new upgrades they've made to function calling as well. So you've got all of that to look forward to. If you want to stay up to date, obviously you should subscribe to the channel. Thank you for tuning in, and I hope you found this useful.